Well, hello again. So I realized that I left off one of the examples on your video today that I intended to put on there because I put it on the honors video and thought it was on yours, but it's not. So if you are having trouble with the second question on the learning journal, this is going to help you with that. And that is because we are going to look at an additional formula that is very similar to half-life. So the reason the half-life formula works out the way it does, okay, whenever it's decreasing by half, whenever we have something in the form of 1 plus or minus r, that r is the rate or the percentage in which it's decreasing or increasing by. But if we look at those things combined, that's the factor at which we're increasing it or decreasing it by. So very similar to when we did the Desmos activity with the tennis balls, the value that you were plugging in for B, that was the factor at which it was decreasing by for each bounce. Okay, so that's how much, it wasn't necessarily the percentage, but the factor that each bounce was lower than for its previous time. Very similar concept in half-life. What's different with that half-life equation is that we're dividing it by that whatever the half-life is, because every period it's not decaying by half. It takes a certain amount of time. So if I were to just use this equation, and let's say I wanted to know how much was left after 20 days, okay, well this would be the formula I would use assuming every single day it's decreasing by half. Since that's not the case, I need to consider how many times that actually occurs. That's why I divide it by what the actual half-life is. So if the half-life was 4 days, there would be 5 periods in which it would decrease by half. So 20 divided by 4 would give me that 5, and that would allow me to say, hey, 5 times I'm multiplying this by 1/2 and getting half the value. This concept in this formula holds true if it's not half-life, but if it's also increasing. So if something is doubling at a certain rate every so often, we essentially have the exact same equation. The only difference is instead of 1/2, I have a 2 there, because that's what's happening. I'm multiplying it by 2. But again, it may not happen every single day. It may happen after a period of time. So let's look at this example. It's down here. So the bacteria in a culture is doubling every 4 hours. So if it's doubling every 4 hours, there were initially 30. So here's 30. I want to know when there will be 300. So again, if I just call this x, that's not going to be enough to consider the fact that it takes every 4 hours in order for this to actually occur. So what my time is, I have to divide it by 4, because again, that's how many periods it's going to actually double. Now with this set up the way it is, x is just the total number of hours, because x over 4 would be the number of doubling periods that we have. I can set this equal to 300, and at this point I can go ahead and solve. So I can divide by 30. I can write this as log base 2 of 10 equals x over 4, and then I can multiply by 4. So very similar setup. This also holds true for your learning journal question. The only difference is it's the same setup, but it wants to know if it's tripling. Well, if it's tripling, it's the same concept. I could just make this 3, because that's the factor that it's increasing by. So really the big thing just to understand from this equation, if it's decreasing by a certain period every however many days, hours, months, etc., we need to consider that in the exponent. The other thing is that if we're looking at a factor of increasing or decreasing, we don't have to do the 1 plus or minus r. The 1 plus or minus r is what we use if we know the percent, the rate, okay, as opposed to saying it doubles, it triples, it is cut in half. The other thing I wanted to show you guys is an example of what you guys will see on your test. And that is these 4 equations right here written in this exact form. This is what you'll be given a copy of on your test on the questions that are application-based. So you will not have to memorize these formulas. You just need to know when to use them and what they stand for. You'll notice now that equation that we talked about today, the yt equals y naught e to the rt, you'll notice that is not on there because that is not, you do not need to know that for your test. The focus is going to be on these setups because that is the majority of what we're using. That other equation, I really wanted you guys to see it just because it will come up in pre-cal, but we are not going to see that on your test and we're not going to use that too much in here. We're really going to have the main focus on these 4 equations. And again, you do not need to memorize what those equations are, but if you see them, you need to recognize when do I use it and what do those values stand for. Okay, so that is it for the little supplement for you guys. If you have any questions, then feel free to send me an email.